Okay, so a couple more examples to just flesh out a couple more of these properties of reflections, and then you'll be ready for your problem set. Okay, so I've drawn a line, L, a point on the line, A, and then a point over here off the line, point P. And I'm just going to quickly reflect this. Sometimes it's hard to draw a straight line. So there's my line, my point A, and point P. All right, and I'm going to reflect this and match that up. So over here I've got my point, my reflected point, and that's going to be P prime. And of course A prime is the same as point A. So there's my P prime. And I want to look at this because what we just read says that lengths of segments are preserved in a reflection. And we saw that in the example that we did. So I'm going to draw a segment right here. This segment crosses our line at point O. We're going to call this point O. So essentially it makes two segments. We've got OP right here, and we've got OP prime right here. So because length is preserved in a reflection, distance is preserved, we could say that for these segments, the lengths are equal. So the lengths of these segments are equal. Okay. Another thing is that P and P prime are directly opposite one another on this line L. And so this is a perpendicular segment here. So what we have is that the line, our line of reflection, is a perpendicular bisector of P prime P. Okay, line of reflection, I'll write this, is a perpendicular, and I can use that for perpendicular, bisector of this segment P prime P. So this line right here is cut right in half. And that's going to be important when you're doing these reflections. We're going to do some on the coordinate grid too. And just to know that that reflection is going to be the same distance directly opposite the line of reflection. Okay, here's another example for us to look at. Under translations, we looked at parallel lines and what happened to parallel lines on when they are translated, and we found out that translations map parallel lines to another set of parallel lines. So we're going to look at that right here too. So I've got a line of reflection drawn right here in the middle. Here's my line of reflection, M. And I've got line L1 that I'm going to reflect. And I've got L2. And I've drawn these so that they're parallel, L1 and L2. So L1 is parallel to L2. And I want to see what happens on reflection of those. Okay, so I'm going to flip my diagram over. And here's what the reflected lines look like. So I've got line, this would be line L1 prime, line L2 prime here, and I can draw them, my pencil, there's points. And so obviously, since we're flipping them over and we see that this is a mirror image, we can see that reflections are going to take parallel lines to a new set of parallel lines. So there's 1 and there's 2. So this would be L1 prime, the reflection of L1, and this would be L2 prime, or the reflection of L2. Okay, and we can make a case for that. We can make a proof for it, but I think for now, this will be good. We'll probably get back to that later. Okay, so what I'd like you to do now is look at exercises 6 through 9 and take a few minutes to do those on your own. Just go ahead and read it and answer the questions, and then we'll come back and correct those, and then you'll be done.